All right.
You have to get a T. You ready?
All right. So we back. We just solving problems again, right? So we're gonna take the test on Monday. And like I said, we're just gonna keep solving problems every day until Monday, till game day. Practice every day, right? So let's go to number 28 on page 44. Number 28 on page 44. All right, so number 28 on page 44 says, in coming to a stop, a car leaves skid marks 65 meters long on the highway. Assuming a deceleration of 4 meters per second squared, estimate the speed of the car just before braking. So let's follow our problem solving strategy and let's walk through it.
This one sounds like it's gonna be hard.
Hmm?
It sounds like it's gonna be hard.
Really? Not really.
Or like lengthy.
Mm-mm. It's one step actually. If you pick the right equation. Right? And that's what excuse me, you get better at over time. Is at picking the right equations. But you gotta do it to get better at it, right? That's why I say STEM is a lot like sport, right? The only way you get better at sport is doing it. Okay? You can read all the books you want, memorize all of whatever you want to memorize. But until you exercise your mind in that way, you will not get stronger. You have to exercise your mind in that way. So, what's the first step in the problem solving strategy? Okay, and so in problem number 28, what are we looking for? Speed. Let me see. Yeah, speed of the car, right? Just before braking, right? Speed. Okay. Yes. Okay. So we're looking for a speed. Or we can always say, or a velocity. We want to put the direction on it. It's a velocity, right? V. Same thing as this. V just has a direction. Okay? Now the next step is to do what? Write down some givens. What are our givens?
You have a distance.
Okay, we have a distance. We call that x. And how much is that?
65 meters.
65 meters. What else do we have?
Deceleration.
Say what?
The deceleration.
Deceleration, or it's an acceleration with a negative value, right? For what? Meters per second squared, right? What else? Look at your context clues.
A stop.
So stop. So then so this is my what? This will be my what? What we're looking for is our what? Initial speed. Right? And so our final speed is what? 0. 0. It would be meters per second, okay? Or if you want to call it V, right? Call it V. Might make it a little more obvious for you when you pick the equation. All right? So is that it? That's pretty much it, right? So now what? We write some physics, right? So which equation am I going to use for this? We're trying to solve for speed, right? We have distance, we have acceleration, and we have final speed. So you should go look at those list of equations that we went over, right? They should be in your lecture slides, right? All
The golden rule?
the golden rule. That's what it is, right? So it's the golden rule that's good here. Golden rule, right? Because we have a final, we have an acceleration, we have an x, right? And what does the golden rule say? It says what? V final squared minus V initial squared equals 2ax minus x final. That's just the distance, right? X naught is 0. X final is 65.
Is the way you wrote it and V squared equals V naught squared, is that the same thing?
Yeah, that's just, you can just bring this over.
Okay.
Same thing. Right? So what you're doing is, so what we doing, so we can just take this equation, right? And then we'll just take all of this, right? We could either take all of this and bring it to that side and bring the V initial squared over to this side, right? That's what y'all wanna do, right?
Yeah.
Okay. Right, so it'd be what? So it'd be, so let's write it from left to right. V initial squared is gonna equal what? So it'd be V final squared minus what? 2ax final minus x initial, right? Everybody following that? And then obviously, we take the square root of both sides. We're gonna get what? V final squared, right? We take the square root of it, gets the square root, minus 2ax final minus x initial. Now we can just plug in our numbers, right?
Why did we square root it? Why did you square root it?
Cause we're trying to, cause it's squared.
Oh, gotcha, okay.
Right? So this is 0.
Mhm.
So 0 squared, 0 meters per second, square, minus 2 times what? Minus 4 meters per second squared, times what? 65. Right? And so this and this gonna be your positive, right? So you're gonna be taking the square root. So this is obviously 0. Right? So our final answer is gonna be what? Negative 2 times negative 4.0 meters per second squared, which is 8, right? Times what? 65. 65. And then you square root that. 8 times 65 is what? 522. All right, so I get 22 meters per second. 22.8. Final answer. 22.8 meters per second. We got all the right units, right? Yep. Any questions about that? Excuse me. Concerns or comments? All right, let's move to 39. Somebody want to read 39 for me?
A stone is dropped from the top of a cliff. It is seen to hit the ground below after 3.55 seconds. How high is the cliff?
All right. So first step is to identify what we're looking for. What is that?
Height.
Distance, height. Yep. Height is a what? Vertical distance. All right. So we're looking for distance. And since it's a height, we'll call it y, right? And it's gonna be in what? Meters probably. Call it y because it's vertical, yes.
Just where you use the gravity constant, or
Huh?
in the given, would you use the gravity constant?
If we're talking about acceleration,
Oh.
yep.
Okay.
In the y, yep, that is the acceleration in the y axis, in the y direction, always, right? Only in the horizontal does it have to be specified, right? So they're expecting you to pick that up, right? Pick that up. By doing enough of these problems, you'll see it. You'll see that pattern. You'll see anytime they specify acceleration, it's horizontal. They don't say, they're gonna say, oh, a ball is dropped.
Then you have to use the.
Then you have to use the context clues and say, oh, well, it's undergoing gravity. So number 2 is what? Second step is to identify the givens. So what are they?
Time.
Huh? We're on 39, right? What's the givens?
Time.
3.55 seconds.
We have time is 3.55 seconds.
And then
Then what else? Look at what it says. Look at what the problem says. What is going on here? Huh? Yes, because why? It's dropping. You're dropping it off of the cliff. Right? So acceleration is gonna be what? G. Right? Which is what? 9.8. 9.8 meters per second squared. Okay. All right. Now is that it? Is that it? Is that all the information we have there? Yeah, I think so. Now what? We write the equation. So, if it's dropping off the cliff, then what equation are we gonna use? Free fall. And what is free fall equation?
X equals x
Yes.
Oh, wait.
But in this case, we're gonna change it to what?
V?
Y.
Oh.
Y. Right? But we're gonna change, yeah, we're gonna change that too though, right? Cause see, I write both of them, right? So what you see, you just said it's x equal what? X naught plus v zero t plus
1/2 AT squared.
1/2 at squared. Plus 1/2 at squared. Well, when we, that's what? That's horizontally. We can write this same equation vertically by writing what? Y equals y naught plus, and then when we get to projectile motion, these two are gonna split into x and y, and you're gonna see, right? So you're gonna have to specify which one this is, if it's VOX or VOY, okay? But we're not there yet, all right? So, but we just take them and split the equations up, right? And we make one for X and one for Y, right? And so, but it's the same equation though, okay? This one just represents motion horizontally. This one represents motion vertically. So it'd be VO in the Y, so this would be in the X.
Gotcha.
We're not there yet, but I'm just letting you know that's when we gonna get there. Plus, and this is gonna be 1/2 what? G T squared. Everybody see that? You see the difference? One is horizontal, it has A, so A has to be specified. One is vertical, has G, stands for gravity. All right? So that's the equation we're gonna use, right? We're gonna use the vertical one, right? So this is what? Horizontal. And this is vertical.
So, for instance, we would use the horizontal one for whenever the acceleration is
Constant.
It's constant, okay.
Whenever they say the jet is moving at a constant acceleration, that's when you use that one. But whenever they say I drop something,
You're using this one.
vertical.
So
Right.
is that T, added to both the?
Yes, this is a T, a time. This is from, right? This is the same T here. And this is plus. This is plus, plus, plus. These are T's right here. See that? Horizontal distance, vertical distance. Okay, so we're gonna use this one, right? Because we said we dropped off of a cliff. Right? So we use this one, and we say right here, y equals what? Y naught. So what's the initial distance? When I drop something. Got it here, and I'm gonna drop it. As soon as I drop it, how far has it traveled? Zero. So y naught is 0. Okay, so how about let's just write it here. Okay, we're using this, huh?
Sorry, so unless it's specified, we should always assume that the initial anything is 0?
Yep.
Okay.
Unless it specifies it, yes.
So it has to-
That's the assumption of initial.
Gotcha.
Unless they say, you know, and I won't give you any problems like that in here, okay? That's like for people who physics majors and stuff, you know, where initial, you know, something might be already happening and then, you know, everything in here, we're gonna be, initial is gonna be t equals 0 and x equals 0, more than likely. If it's not, I'm gonna tell you. Cause that's how you, throw a curveball to a physics major, is you don't make the initial zero, right? So that's like a lot of other stuff, and it's not really important here. Okay, so that's zero. So what happens when I drop something? What's the initial speed?
Zero.
Zero. So, and we can write that in our givens, right? Because we knew that from we knew that from what? Just context clues. We knew that y naught was zero, and we knew that what? V naught was what? Zero, because the person did what? Dropped it. Now, if they had thrown it down, then it's not zero. It's like when you throw it up, they always tell you what? With an initial speed of this. Because you gotta, in order for it to go up, I gotta give it an initial speed. But I don't have to give it no speed to drop it. Because gravity is gonna pull it. Right? So this one is, so this term goes to zero. If I drop it, right? Initial speed is zero. That term goes to zero. Now I'm left with what?
Time. Oh,
No.
what about?
Remember this time is, this V is, this is all one term.
Oh, okay.
So once this goes to zero, that takes care of that T.
Oh, okay, gotcha.
It's gone now. So now we're left with what? 1/2 G T squared. So
Can
what?
you replace it with the number, or you just leave it as G?
No, we're doing algebra right
Oh.
now. Yeah. Right? We get the algebra right first,
Okay.
then we put numbers in. Okay? So we say what? 1/2 G T squared. And now we do what? Plug in the numbers. 1/2, 9.8 meters per second squared, and what? 3.55 seconds squared. And what's that number? Right? And just like I did my other class, I think we need to practice using our TI 85 or our graphing calculator, whatever kind of graphing calculator you got. But we need to practice and make sure that everyone is using parentheses and the E, not times 10. Y'all know what I'm talking about? When you write a scientific number, a number in scientific notation, you cannot write the number and then you cannot enter 7.35, then enter times 10, and then raise that to the -4. The calculator doesn't understand that. Okay? Calculator understands that as 7.35 times 10, right? Right? And then, cause I don't even think it even understands this. Right? That's you understand that. You understand this to be raising it to the 4th power. The computer don't understand that. That's why you have to enter what? 7.35 e to the -4. Okay? And we want to make sure we're using our parentheses correctly. Always. Right? In this case, I don't think it matters much. So did we get a final answer?
17.4 G squared.
You say what?
Yeah, cause I got 61.75.
61.75.
Yeah, I got the same thing.
61.75. What?
Oh, meters.
Meters. for the height of the cliff, right? See how easy it is to forget what you was looking for?
Yeah.
All right, so that's free fall, right? That was free fall.
So the instantaneous, all that stuff, like,
No, that's calculus. That's yeah, instantaneous velocity and all that. That's the first derivative.
what about like displacement? Will we ever do that?
Displacement, yes.
Okay.
Y'all been doing displacement. Displacement is x final minus x initial,
Oh, yeah,
right?
yeah.
So I think if you concentrate on the little tutorial that's already on your Moodle, right? You should be, if you concentrate on that and making conversions using the chain link conversion or the T-chart, you should be fine, right? And learning how to use your app correctly or your calculator with the parentheses and the exponents, okay?
My main problem, like when I'm doing the homework, is like figuring out which
Equation.
equation.
Yes, that's the part. That's the part. That's just a learning curve.
Okay.
It's just a learn. It's just painful. It's a process. I went through it, and you know, I had to do it year after year after year, right?
And we're not gonna be given any
So
of
we have
the
to
equations,
memorize
like,
them.
we have to memorize them.
I mean, you know, the equations. I mean, like I say, if you can tell me, if you can give me the correct name of an equation, I'll give you the equation.
What did we ask you?
Yes. If you say, Dr. Stewart, what can you tell us what the constant acceleration equation is? I'll give it to you.
Okay.
But you have to say that. You can't say, you remember the one, that one.
Okay.
You have to say the constant acceleration equation.
Gotcha.
If you know that much,
You'll tell us.
then you're good. Yeah, you're
Okay.
good. The rest is just math.
I can rock with that.
Just,
Yeah. So learn. So it behooves you to learn what things, the names of things, and what to call them.
Okay.
That's a big thing in physics, right? Because there's so many moving parts that you can't just, and see, I did this when I first started doing physics, and I learned how to be more descriptive in my speech and everything. Like it, you know, just everyday talk when I'm talking to people, how to communicate. Like you can't say the thing, that, this, right? Everything has a name to it. You just have to learn what it is and use that, right? But see, in our everyday speech, we just you know, yeah, we just generalize stuff, and we don't care to actually know what things are called. We just, if we hear somebody else call it something, we might say, all right, that's what it is, right? But here, you know, there's no ambiguity about anything. You could figure out what things are called here. All right, so let's see. We at 12:30. So let's look at, and let's do one more free fall. And then we're gonna stop. Okay. All right, let's look at number 46. All right, number 46. Now we're starting to get a little bit more, you know, a little bit more sophisticated. But we still use the same steps as we always did, as we always do. All right? Nothing different. Just have to be a little more careful. So, like I said, we're recording this, all right? And so, hopefully, you guys will take advantage of the recordings, go back, look at these recordings, and actually break everything down to every step, right? So you have no, no question about nothing. It's really just a matter of you looking at it, right? The more you look at it, right, the more questions you're gonna have. It's just natural, it's just a fact of life. If you look at it more, you're gonna have more questions. And if you do that, the more times you do that before test day, then the more questions you can get answered before test day, right? This is the key to it. It's nothing more than this, okay? So, we on what problem I said? 46. All right, so somebody want to read that one? Stone.
A stone is thrown vertically upward with a speed of 24 meters per second. How fast is it moving when its height is at 13 meters?
That's A.
Yeah, oh, all of it?
Yeah,
Oh,
the
how much time is required to reach this height, and why are there two answers to?
Come on, y'all. It's easy, right?
Oh, because it's gonna be two
Cause it's gonna be what?
speed? Well, it, cause it says
No.
speed and height.
No. It said 2 times. You're gonna get two times.
Yeah,
What do the 2 times represent?
Oh, when it reaches the height
And
and
when it come back down.
Right.
What goes up?
So we're doing gravity again, right?
Yes. Wait, Newton's laws. Yes.
Is this next Monday?
Yes. All right, so I'm listening. Number 46. A. How fast is it moving? So we're looking for speed or velocity, right? Let's say velocity now, since we've gotten advanced now. We're past speed, okay? Everything is velocity from here on out. Even if they say speed, we're gonna say velocity. Same thing. Velocity just has the direction on it.
We have, our given.
Yep.
Oh.
So that's for velocity
Oh, and time.
and it's probably gonna be in meters per second, right? So we got what? Givens. What do we have?
Vertical distance.
We got a vertical distance.
I mean, speed.
Uh,
The vertical speed or the vertical velocity.
we got a speed, right? And what kind of speed is that? Initial, right? Initial speed of what? 24 meters per second, right? And what else?
13-meter height.
13-meter height. 13-meter height, so let's call that, so since we're going up, right, we're gonna call that Y, right? 13 meters, right? What else?
Initial speed?
Hmm?
I mean, wait, oh, never mind. I think that's, we have an initial height.
Will gravity, do we need gravity?
Well, yes, we do need gravity, right? Because we did what?
Throw it.
Threw it up. Right.
So, but, can we draw this one? So,
Okay, we can do that. Alright,
But the initial height will be 0.
the initial height would be 0.
Yeah, cause,
Okay. Initial height, why not?
oh,
Yes, it will be,
okay,
You're right.
I see now.
right? So then what equation are we gonna use then? You should know.
isn't it it's gonna be the golden rule.
Golden rule again. That's why it's called the Golden rule.
Wait, but the golden rule and the free fall got the same oh. Okay, also we use the free fall when we have a time. Right?
In some cases.
Because that's the only constant that's missing.
No, but see, in some cases, when we could solve the quadratic equation, and it gives us the 2 times, when we don't have time, so we use that free fall equation in that instance. So not necessarily, not always. So don't, that's one thing, don't ever think about as something being always the case in physics. It's probably not, more than likely. Not always something, right? Very few things. Okay? So we can use the golden rule here. V final square minus V initial square equals what? 2A, and then instead of X, we're gonna write what? Y. Y final minus Y initial. Right? So, we're trying to find what? Final speed. Right? So, then, we know we have what? So we can rearrange this equation, right? So what? The final, right, equal to what? The initial square plus 2A YF minus Y naught. And then of course I take the what? Square root VO square plus 2AY final minus Y naught, right? And then I do what? Plug my numbers in now. That's what? 24 plus 2, right? And because so I've got one thing, right? Negative 9.8 meters per second, y squared. Why is it negative?
Because it goes against.
It goes against it. You're throwing it up, it's working against it. So it's negative 9.8 here, meters per second squared.
Wait, hold on.
And, wait, what did I? Yeah. Times what? 13.
So wait, I got lost.
Where'd you get lost?
Question. So we still even if we're throwing it up, we still use that acceleration?
Yes, that's the gravity. You're just working against gravity when you're throwing up. That's why it's negative. And so this tells you what the speed is at 13 meters.
Wait, say that?
So initial speed was 24.
Yes.
What's the final speed gonna be when it hits the top? 0.
Oh.
Yes.
Okay.
This is telling us what? It's gonna, before it reaches 0, when it hits 13 meters, it's gonna be traveling at this speed, which we just calculated.
And that's what we're finding.
That's what we're finding,
Gotcha.
right? Now see, what if we said, well, if we said, I can use this same problem and I can take this 13 meters away and say, well, what distance does it reach at its maximum height? And in that case, you would do what? For the final speed, you just write what?
0.
0.
Oh. And then something.
And then solve for y. And it's gonna tell you what height it reached. And it's probably gonna be larger than 13. Right? Y'all see how this is all like puzzles? And they have to make sense. Right? And what I'm telling you is that I've been doing this a long time, right? So it's gonna appear to be like really easy when I'm up here with you doing it, you know? Cause I've just been doing it so long, right? And I mean, you know, just like anybody else, like some of these older guys here, the gray beards and all that. I mean, there's a guy named Yang, Dr. Yang. He could solve every problem in this book off the top of his head. Every one. You Chinese dude when I was in school here. I think he's still alive. He's about 100-some years old. Yeah.
That's a talent.
So, but that's because you gotta that's because he keep his mind working.
That's crazy.
Probably has a garden and all of that,
Well,
you know?
yeah.
Yeah. Tell. All right. So let's get a number. What's the number? Square root. It's gonna be 24, right? It's square rooted. Well, I would do it. Okay, I would just square it, then put the number there plus that, and then take the square root. Matter of fact, let me do it, so we can all. You know, I have a tendency of not doing it, and then somebody will say, "Oh, well, I got something different." All right, that makes sense.
Is it a negative?
Nope.
Oh, I got. You don't know what I got. 17.9?
Yes. So that makes sense, right?
Yes.
If I threw it up with 24 meters per second, then when it gets to 13 meters, it should be traveling faster or slower. If I threw it up. Because it's going to eventually do what? Stop. So we got what? 17.9 meters per second. And that's what I mean about once you get a final answer, you should think about, is your answer reasonable? Does it make sense? That was the first part, right? Now we gotta do what? Find the time. How much time is required to reach the height? How much time? How do we do that?
Oh, we could use, this is our sign?
No,
Oh.
not that easy. I thought you was gonna say it.
Wait, no, because if you do t equals distance over speed,
Huh?
this, if you do t equals distance, no?
Because you're gonna get 2 times.
Isn't that what we? Oh, the quadratic.
Gotta use a quadratic, right?
But
Because if you're throwing something up, you're gonna get 1 time going up,
Oh, and then
1 time coming back down.
But isn't that what we're looking for?
What?
Who says why are there 2 answers to B in the?
Yeah, well, yeah, that's what we're looking for, the time. Yeah.
Oh.
And they're saying, once you find the time, they didn't, see, before you, I mean, I guess at B, you wouldn't know that you would get 2 answers until you did it. And then you get to C and you say, why are there 2 answers? See, I just went ahead a little ahead and told you. There's 2 answers because you're talking about 1 going up, 1 coming back down.
Gotcha.
All right? But let's go ahead and set that up, and maybe you can go home and practice by yourself and solving that quadratic equation, okay? Because like I said, all right, don't just take what I'm saying for granted, y'all, okay? Telling you the truth, that you're gonna have to struggle and bump your head on your own, okay? It's gonna seem like you're not learning nothing, you just wasting your time, blah, 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 blah. I guarantee you you're not. I guarantee you. Gotta do it on your own though. With nobody. Nobody's help. And I probably shouldn't have erased everything, because it's the same problem. But B is what? We find time, right? Find time. Okay. Of course, it's gonna be in T seconds. And our givens were, we had what? We got initial of what? 24 meters per second. What else we got?
The V final is 17.9.
All right, we don't need B final though. Not for this one. Yeah, we don't need B final, right? What else? What was the other? Then we got A was what? Negative 9.8 meters per second squared. And what else we had?
13 meters. Well, that was what it asked in A. I don't know if that's still given.
You say what?
Like the 13 meters, the height.
We have distance.
Oh, the distance.
Alright,
Since it
so
was in the other-
then let's set it up. So then, all right. So let's say 3. And we're using our y naught plus v0 t plus 1/2 a t squared, right?
So we're using free fall?
Yeah. That's the one where you get the quadratic, right? Okay. And so we're gonna have what? Y equals let's see, hold on. I know this is gonna be 24t plus 1/2 negative 9.8 t squared, right? And y initial, let me see. Okay. Let me go back and make sure we get this right, so we don't add to any confusion. Plus, let me make sure I get this right. Where's the problem there? How much time are we there? Okay, yeah. So, so in this case, we're gonna say, so we're gonna use, oh yeah, this is here, so this is gonna be, this is gonna be 0, and this is gonna be what, 13. There we go, 13, right? This is 0 meters. Okay? And that's our 24 for our initial speed. Boom, boom, boom. So now we got a quadratic. Right? So let's flip it around right to left, and I'm gonna let y'all finish it up, all right? So let's flip it around. So let's just do that. That's gonna be what? Negative 4.9, right? T squared. Plus 24t minus 13 equals 0. Right? So then A is equal to what? Minus 4.9. B is equal to 24. C is equal to minus 13.
And then you just plug that into the quadratic formula.
Yes. And you should get 2 times, right? You should get 2 positive times. Okay? So remember, before when we did this, one time we got was negative. And remember I never told y'all that, but whenever we do that and we get a negative time, we just disregard it, right? Because negative time doesn't exist. We take the positive only, right? But in this case, we're gonna get 2 positive times. That's why we get 2 solutions. So yeah, so go here and just x equals minus b plus or minus square root b squared minus 4ac all over 2a. And you should get x, should get 2 times, both positive. Right, one going up, one going down. All right, folks. How many did we cover today? That was just 2 problems?
3.
That was 3? All right. All right, so what's today? Wednesday? Yeah. See y'all on Friday.